Hello everyone. On this video we will be covering optimization problems. Okay, now optimization problems mainly look for the minimum and maximum values when derivatives are involved. Okay, so if you look back to the related rates video, the first three problems are optimization problems because they ask for the minimum and maximum. So if you want to go back and look at those in the related rates video, you can. The reason I'm kind of combining the two is because I don't like having separate procedures for approaching story problems like this. Okay, so they both will have the same steps and procedures. I'm kind of just mixing them in. So these examples I'm going to give you on this video are also optimization problems. Okay, but again, they have the same steps as the related rates. Okay, so step one, just to go over them again, identify all given quantities and equations. Okay, make a sketch of it if it helps. Okay, now this step here is a big help. Okay, step two, you want to write your primary equations. For the quantity to be maximized, minimized, or the rate of change solved. To be maximized, minimized, or rate of change solved. Okay, so again, these step two, if you're finding the maximum or minimum, you're doing optimization. If you find the rate of change solved, you're doing related rate. So that's why I'm kind of combining them into a certain set of steps. Okay, now three, and this is only if necessary. A lot of times you don't have to do this, but sometimes you do. If necessary, reduce the equation in step two to having one independent variable. Okay, now this could involve another equation. So this could involve a secondary equation. All right, now step four is another one that it's helpful to write down, but in a lot of cases you don't have to because you can kind of know what it is, but sometimes it's good to write it down so you don't forget. Okay, and that's identify your domain. And again, just if necessary. All right, step five, you want to determine your minimum or maximum values or rate of change using the techniques that we've learned. you have learned so far. Okay, and those techniques could include your first or your second derivative test, critical points, and etc., and so on. All right, so like I said, these are all the steps that are identical to your related rate steps. They just apply to both. All right. So if you are still writing this, feel free to press pause. But we're going to go ahead and jump to our first example. Oops. Okay, so for this example, what if we have the second number is the reciprocal of the first, and the sum is a minimum. Okay, so we want to find two positive numbers, or the two positive numbers, that satisfy the given requirements. All right, so for this one, we don't really have to draw a picture, but we can still have our identify our equations. Okay, anything that's given to us. Okay, so your first step, what if we let x represent a positive number? Okay, so now it tells us here that the second number is the reciprocal of the first. So if x is our first number, the second number is 1 over x, the reciprocal of our number. Let me clean up that right there. Reciprocal of that number. All right, so now we're going to go to our second step, where we're going to look for our primary equation. Okay, so for our primary equation, if you look at the problem, it'll tell you exactly what you're looking for. Okay, it tells you the sum is a minimum. So the sum of the second and first number is a minimum. So the sum is a minimum. So we'll let S equals the sum. And I'll just draw a line through my S so it doesn't look like 5. Okay, so if we add our first number and its reciprocal together, you have S is equal to X plus 1 over X. Okay, so basically what they're asking us is, what two positive numbers would give you the smallest possible sum if you multiply that number with its reciprocal? Okay, so that's our primary equation. Now your third step, you can really skip that. And we know for our fourth step, we just know that x is greater than 0 and 1 over x is greater than 0. Again, you didn't have to write that, but sometimes it's just nice to know exactly what you're looking for. Okay, so now we go to our fifth step. Okay, using everything we've learned so far to find our minimum. So since we're looking for the minimum of our sum, we want to find that critical number, or that critical point. So we look for the first derivative of our equation, primary equation. So partial derivative of our s with respect to x, derivative of x is equal to 1, plus the derivative of 1 over x is just, that should be minus 1 over x squared. And that is because the derivative of 1 over x is the same as saying the derivative of x to the negative 1 power, since that is equal to that. So we bring that negative 1 down to the front, so you have negative x to the negative, and then you subtract 1. So negative 1 minus 1. So that gives us negative x to the negative 2 power, or just negative 1 over x squared. So that's how we ended up there. All right, so we see there that when derivative of s with respect to x is equal to 0, that just means that 1 minus 1 over x squared is equal to 0. All right, so if we go ahead and solve that, and I'll just solve that in the steps over here. We add 1 over x squared to both sides. That's 1 equals 1 over x squared. So if we multiply x squared to both sides, we end up with x squared equals 1. Square rooting both sides, we have x is equal to positive or negative 1. But since we know that x has to be positive, that means x is just equal to 1, which is our critical number. All right. Okay. Now, what does this tell us? Well, it tells us we look at also if we wanted to use our second derivative test, we could just find the second derivative of s with respect to x squared. So to do that, that would just end up being 2 over x to the third. So finding out our critical number, when x is equal to 1, our second derivative with respect to x will end up being positive. So if we plug in 1 here, we end up with a positive number, which lets us know the local minimum at x equals 1. All right, so you can use either one of those and it would have given you the answer. So what does that tell us? The sum is a minimum when x is equal to 1 and 1 over x is equal to 1. Okay, so if you're going to add a number and its reciprocal together, the smallest possible sum of all the positive numbers you can add together would be 1 and negative 1. Okay, I mean 1 and 1 over 1. Okay, if you tried to do 2 plus 1 over 2, you would get a bigger number. If you tried 3 plus 1 over 3, you'd get a bigger number. Okay, so the smallest possible number you could get when you add them together is if you use x equals 1 and 1 over x. In that case would equal 1. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. kind of went over on our last page there. There we go. Excuse me. Okay. So for this one, let's say if we have a Norman window, is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Okay, so we want to find the dimensions of a Norman window of maximum area. But if the total perimeter is 16 feet. All right, now a Norman window, just to give you an idea of what it would look like. You have a regular rectangular window on the bottom and a semicircle on top. Okay, now the dimensions for this one is from the center of the rectangular window to the edge is x over 2. The entire length, that's going to be x. And from here to here, this is going to be our y. Okay, so all the information we need is right here. Okay, now with this one, we're not going to go through the step 1, the step 2, the step 3. We're going to solve it, but we're not going to go through each individual step. And I'm doing that because the guidelines and the steps are more to get you started. The more you practice, you'll kind of come up with your own steps and your own guidelines. So you won't have to use it once you get enough practice under your belt. Okay? Remember, these are just guides to get you started. As you get better, and trust me, if you practice enough, you will get better. As you get better, you're not going to need those guidelines anymore. You're going to automatically know how to approach a problem like this. Okay, you just have to practice. All right, so we're going to solve this. All right, now to get started, first thing we're going to want to know is exactly what is the circumference of a circle. Because remember, we only have a half circle up here. So remember, the circumference of a circle, and that's an entire circle, is 2 pi times the radius. And the area of a circle is pi radius squared. Okay, so those are the old equations from geometry and trigonometry days that are all coming back. Okay, so if the circumference of a full circle is 2 pi times the radius, we only have a half circle here. So the circumference of a half circle would just be half of that. So that would be 2 pi r divided by 2, where those two are going to cancel out. So it's going to be pi r. So we'll let our circumference of a half circle, I'll put that little h to be half instead of just circumference, is equal to pi r. Okay, so these are all the things we're going to need going forward. And remember, the circumference is just the length of the outside. Okay, now we see here that the radius of our circles, remember this is x divided by 2, that's the radius of our circle. So since our radius is the length of x divided by 2, that means our circumference is equal to pi times the radius, which is x over 2. Okay, now we think of our entire thing, because we already have the circle taken care of. We have our equations for our circle. Now we think of the perimeter of the entire thing. So we look at the perimeter of all three sides and the perimeter of that half circle. Because remember, the perimeter is just the length of the outside. You don't have to add this one. Okay, so this one you can kind of just ignore. But it's this side, this side, this side, and the length of the circle. Okay, so our perimeter will equal x plus y plus the circumference of our half circle. Okay, or the circumference of our half circle. Okay, now just to kind of simplify that, remember the total perimeter is 16 feet. So you have 16 equals x plus x, which is 2x. I mean, it should be 2y. Sorry about that. I'm glad I caught that. So it should be x plus y plus y. So that should be 2y plus x plus pi x over 2. All right. Now, what we're going to do is we're going to solve for our y, because we don't need a function of x and y. So if we solve for y, it will just be a function of x. Okay, so we only have to worry about that one variable. Okay, so if we solve for y, we're going to multiply each term, or each side of each term, by 2. And that's to get rid of that fraction. Okay, so if we multiply every term by 2, 16 times 2 is 32. 2y times 2, 4y. Oh, move that up some. X times 2 is 2x. Plus 2 pi times x over 2. The 2's will cancel out, and that just gives you pi x. Okay, and then from there, we solve for y. Okay, so if we solve for y, that means we subtract the 2x and we subtract the pi over x and we divide everything by 4. You have y equals 32 minus 2x minus pi x over 4. All right. Now, going from there, we're looking for the maximum area. Remember, that's our problem. That's we're looking for the maximum area. So since we're looking for the maximum area, we know the total area is equal to the area of the rectangle plus the area of the half circle. Okay, where we know that the radius is equal to x over 2. All right, so that total area would have to equal the area of the rectangle. Remember, the area of a rectangle is the length times the width. So the area of just the rectangle is x times y. You have x times y plus the area of the half circle. Now the area of a full circle is pi radius squared. So the area of a half circle is just that divided by 2. So if we divide that by 2, we have pi over 2 times our radius squared. Now our radius, we already figured that out, is x over 2. So that's x over 2 squared. Okay, so remember, this is the area of the rectangle. This is the area of the half circle once you replace the radius with x over 2. All right. Now, once again, we can't have a function of x and y. So this is why we did all of this, because now we can just replace that y with this function of x up here. Okay, so that means your area is going to equal x times this value of y, 32 minus 2x minus pi x over 4, plus the area of a half circle. That's pi over 2 times x over 2 squared. Okay. So if you're still writing, we're actually going to continue this on the next page. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to the next page. Oh, I'm right to continue this. All right, so we know, just writing down what was on the last page, it was x times 32 minus 2x minus pi x over 4 plus pi over 2 times x over 2 squared. Okay, so this is just where we left off on the last page. All right, so that means your area is equal to, if we distribute that x, 32x minus 2x squared minus pi x squared over 4 plus, you have x squared over 4 times pi over 2 will give you pi x squared over 8. All right, so if we multiply this by 2 over 2, or if we simplify it a little bit more, you end up with the area is equal to 8x minus 1/2 x squared, because you're just kind of simplifying each one of those, minus pi over 4 x squared plus pi over 8 x squared. Okay, so now we have the formula for the area with one independent variable x. Area formula of one independent variable x. Okay, so we no longer have a function of x and y. All right, so now that we have the area formula with one independent variable, we can use that to find the maximum. Okay, to do that, we have to find the critical point. So the derivative of a with respect to x is going to equal the derivative of this term. 8x is just 8. Minus the derivative of 1/2 x squared. Bring down the 2, it cancels out. Subtract 1 from there, it's just x. Minus the derivative of pi over 4x squared. We bring down our 2. The 2 and the 4 cancel. So you end up with pi over 2x. Well, the x is actually not underneath, so I'm going to make sure that's up high enough. There we go. Plus the derivative of pi over 8 x squared, bring down the 2, that ends up being pi over 4 x. Okay. And actually, we can go ahead and combine those two. So we can make that equal 8 minus x. And those two will simplify to give you, and we'll actually factor that out. We have 1 plus power of 4. If we combine all of these, well, we can actually leave this by itself because of this. We're just factoring an x out of all three of those. So we're combining those two. So when you factor an x out of here, you get your 1. And once you combine those two and you factor out your x, you'll get power of 4. All right, so this is our first derivative. So of course, we have to find whether our first derivative is equal to 0, which means we want to know where 8 minus x times 1 plus power of 4 is equal to 0. Okay, so if we add x times 1 plus power of 4 to both sides, then subtract, we know that x can equal 8 over 1 plus power of 4, which if you simplify it by multiplying the denominator, well, the 1, making that 4 over 4, and having just 1, 4 plus power of 4, then multiply the numerator and denominator by 4. That will cancel out, and that will end up giving you 32 over 4 plus pi. Just kind of simplifying this one. And this is your critical point. Remember, that's the point where your first derivative will equal 0. Okay, so if we find our second derivative, of our second of our first derivative, remember this is our first derivative, our second derivative will just end up being negative 1 plus pi over 4, because that x will just become 1. And that 8 will just become 0. Okay. Now, what's the one thing we're going to notice? Is that at our critical point, which is x is equal to 32 over 4 plus pi, there's no x to plug in. So at this point, this is a negative number. So that means if you even plug that in, which there's no x to replace that with, it's still going to be less than 0. So we know that that point gives us our maximum. When x is equal to 32 over 4 plus pi. All right, take a deep breath. We're almost done. I know this is kind of a long one. Okay, so now we're looking for our maximum area. So if we go back to our y is equal to 32 minus 2x minus pi x over 4, we just plug in our x value, because we already know we have our maximum x value. We just have to find our maximum y value. Okay, so this will become 32 minus 2 times 32 over 4 plus pi minus pi times 32 over 4 plus pi. All of that over 4. Okay, so once you get done combining like terms and simplifying and everything else, you get y is equal to 16 over 4 plus pi. Okay, so you get your x and y value that will give you the maximum area. All right, so that means your maximum area, you get that when x is equal to 32 over 4 plus pi feet, and y is equal to 16 over 4 plus pi feet. Okay, now since this didn't ask for a rounded answer, we're going to leave it like this as an exact answer. Now, if they ask for a rounded answer to so many decimal points, you plug that into a calculator, and it will give you a decimal answer, and you round it to the nearest tenth, hundred, thousands, whole number, whichever one that particular answer asks for. All right, so that's it for that problem. I hope it made sense, and I'll see you on the next video.